Welcome, viewers, to Body Unified Flow. Here we simplify complexity and amplify performance. Today, we're diving into a truly fascinating topic, value stream mapping, or VSM, and exactly how we use it for finding inefficiencies in project life cycles. We're going to focus specifically on VSM in construction and design, and look at how we go about adapting manufacturing tools to project-based environments. You know, if you've ever been on a project and felt like you were just leaking time, money, or resources, but you couldn't put your finger on exactly where it was happening, well, you're absolutely in the right place today. We're going to make those invisible inefficiencies visible. So, just a quick look at the agenda for today's explainer. We'll unpack what VSM actually is, talk about the unique challenges of adapting it to construction, walk through the exact implementation steps, look at some real-world impact data, and then wrap things up. Our main goal here is to give you a practical, data-backed understanding of how to eliminate that hidden waste in your projects. All right, let's jump right into Section 1, the current state of projects. To really appreciate the solution we're talking about today, we first have to honestly assess our starting point. Let's be real. Most project life cycles in architecture, engineering, and construction start in a terrain that is frankly filled with persistent, hidden problems. Problems we've just kind of grown accustomed to working around, right? At the core of this are what we call non-value-adding activities, or NVAA for short. Research going all the way back to Koskela in 1992 highlights that these are the completely unnecessary tasks and material losses within a project. I'm talking about crews just standing around waiting to start, the heavy costs of poor quality, rework, which is a huge one, and unnecessary transport across a massive job site. It's improper management, it's poor constructability. And these aren't just minor headaches, they are literally invisible dreams on your project's lifeblood. Interestingly enough, the literature actually shows that a vast majority of the waste we hit during construction was basically baked in during the design phase because problems went undiscovered. Okay, moving on to Section 2, unpacking value stream mapping, our vehicle for change. So, how do we cross that bridge from the chaotic current state to a highly efficient, streamlined future? Enter value stream mapping. VSM is a lean management tool, and what it does is visually represent the flow, not just of materials, but crucially of the information needed to bring a project from conception all the way to delivery. It uses a very specific set of symbols to map out everything required to get the job done. By meticulously documenting every single step, it forces us to see exactly where value is being created, and more importantly, where it absolutely isn't. It takes that invisible waste, which is often called muda in lean terminology, and makes it glaringly visible and totally actionable. And if you want to know how severe this problem actually is, just take a look at these numbers. This is from observational data in traditional construction procurement, and honestly, it's staggering. Actual value-adding activities, the work that your client is actually paying for, make up only 17.5% of the process. Think about that for a second. Then you have non-value-adding necessary activities. These take up 31.5%. These are things you have to do because of the way the system currently works, even though they don't add real value. But here is the kicker. Non-value-adding unnecessary activities. A massive 51% of activities in traditional procurement are classified as pure, unadulterated waste. That means over half of your effort is yielding literally zero value. This is exactly why a methodology like VSM is a game changer. As the source literature points out, it allows project teams to distinguish between value-adding activities and non-value-adding waste. Without a map, you're flying blind. You're just guessing where the bottlenecks are. But with VSM, you transition from managing by gut feeling to managing by concrete visual evidence. You stop guessing and you start seeing the exact spots where your time, budget, and resources are bleeding out. Which brings us to Section 3, adapting to construction, and the unique challenges of this terrain. Now here's where the friction happens. Look at the stark contrast here. Traditional VSM was born on the factory floor. Manufacturing environments are highly repetitive, they're stable, the process flows are incredibly predictable, you know exactly what machine a part goes to next. But construction is an entirely different beast. It is dynamic, highly fragmented, unstructured, and totally decentralized. Your job site changes every single day. The weather throws a wrench in your plans. The pristine conditions that make VSM so straightforward in a factory just do not naturally exist on a muddy, chaotic construction site. So that begs a really critical question. How do we successfully adapt a rigid, linear tool built for factories into a dynamic, ever-changing project environment? Because our processes aren't generic assembly lines, we can't just copy and paste the Toyota playbook. Implementing VSM in construction requires some pretty substantial structural adaptation. We have to literally change how the tool is applied to fit the reality of our terrain. Let's look at how we actually do that in Section 4, the implementation steps. To cross that gap from factory theory to job site reality, we follow a very structured three-step framework. Step 1 is benchmarking the current state. You have to establish a baseline. You map the current processes and gather hard quantitative metrics: time, cost, quality, safety. Step 2 is identifying opportunities. Once you have that current map, you analyze it to isolate the bottlenecks and process disconnects. And finally, Step 3 is brainstorming plus/delta items. This is where facilitators get the actual project team, the people on the ground, engaged to pinpoint specific, actionable problems that are killing your workflow. And here is the beautiful part. Once you've analyzed your current state and found those deltas, you don't just complain about them and move on, you design the future state map. This becomes your blueprint. It visually outlines the absolute most efficient way to complete the process. This future state map becomes the ultimate North Star for your team, a newly designed system that actively eliminates double handling, cuts down excess materials, and makes sure information flows smoothly. It's a picture of your project with all that 51% of waste removed. So, does it actually work? Let's jump to Section 5, measuring the real impact. Adapting manufacturing tools sounds great in theory, but let's look at the hard data from the real world. In a detailed study by Gunduz and Nasser on a complex underground pipeline project, applying this adapted VSM framework led to a massive 30.7% reduction in overall lead time. And perhaps even more importantly for the stakeholders, it drove a 20.8% decrease in total costs. By visualizing the redundancies, they were able to deploy highly targeted interventions that saved serious time and serious money. And hey, it's not just heavy civil infrastructure. In a study by Lima and colleagues focusing on architectural residential buildings, they systematically targeted inefficiencies using VSM and achieved an unbelievable 34% reduction in overall project duration. I mean, just imagine cutting a whole third off your construction schedule simply by organizing your flow and getting rid of the stuff that doesn't add value. It even scales down to the micro level. In highly specialized tasks, like an on-site kitchen cabinet assembly, adapting VSM yielded a 22% increase in pure value-adding time. When you eliminate all that motion waste, workers walking back and forth to get tools or waiting for another crew to finish, your skilled labor actually spends their day building value. And the really exciting part is that this methodology is still evolving. Today's project managers are taking VSM and integrating it with modern digital tools to completely amplify its power. We're talking about combining VSM with building information modeling, or BIM. We're using 3D visualization to literally see the physical constraints of a workflow, and running advanced process simulations to test out that future state map in a digital environment before we ever spend a single dollar on site. It's a total game changer. All right, let's head into Section 6 to wrap things up with a summary and our references. Let's quickly highlight what we've covered in our explainer today. We set out to understand how to eliminate hidden inefficiencies, and we've done just that. We visualized how non-value-adding waste silently drains a project. We contrasted the stable factory floor with the unpredictable construction site, showing exactly why adaptation is crucial. We walked through the three-step framework to benchmark, identify, and solve these issues. And finally, we looked at the data proving that this adaptation can slash lead times by 30% and costs by over 20%. Now, everything we discussed today is fully grounded in research. If you're a practitioner, a project manager, or a student who wants to dive deeper into these frameworks and case studies, here are the key research papers and publications that formed the foundation of today's explainer. Thank you so much for joining Bodhi Unified Flow today, where we simplify complexity and amplify performance. I want to leave you with one final provocative thought. You now know for a fact that up to 51% of activities in traditional setups can be pure waste. That drain is happening right now, whether you see it or not. So armed with this knowledge of value stream mapping, what invisible waste are you going to map out and eliminate on your very next project?